Hi everyone, this is Praktis Sumatif, paper 2, question number 7. Now, the diagram 3 shows a container in the shape of prism with uniform cross-section A, B, C, D. AB is parallel to CD. Okay, let's mark it down. And the vertical distance between the two parallel lines is 20. So it's given here. The length of AB and the CD are 16 and 24. So it's marked down in the diagram already. The open top CDHG and the bottom ABFE, they are horizontal planes whereby BF equals to CG equals to 30. Right? So our uniform cross section will be this trapezium. Okay, now let's look at the question, the requirement of the question. It says that the container is filled with water. After T seconds, the water level achieves the depth of H cm and the width of water surface X cm. So by using similarity concept, we're going to express X in terms of H. Okay, let's do that part first. Let me just get the trapezium out. So it looks like this. Okay, this is our A, B, C, D. So AB is 16 cm, and then the CD is 24 cm. And then we have the water level, that is X cm. Now, since ABCD and CDHG, they are the horizontal plane, therefore they're parallel. And our water level will be parallel to the base as well. And then the height, perpendicular height, this is 20. Therefore, the H will be here. This is H. So to use the concept of similarity, we have to prove that, we have to express X in terms of H. Huh? So we shall use the comparison. Okay, the small trapezium compare with the big trapezium. Okay, let's do the comparison. So X over H, it's in proportion to 24 over 20. And therefore, we have just written the X in terms of H. So divided by 4, 6 over 5 H. So we found this. And hence, the question says, show that the volume of the water in the container at time T seconds is given by this. That means we are looking for the volume of the water. So the volume of the prism, V equals to the area of the uniform cross section times with the height or the depth of the prism. So how do I find the area of the trapezium? That is half times the sum of two parallel sides. In this case, is 16 plus X times with the height in between the water level and the base, that is H, and then times with the depth of the trapezium, of the prism, that is 30. So put it in. 2 and 30 can be simplified, and then we have to change the X in terms of H. Yeah? So now we have 16 plus 6 over 5H. Okay, times 15H. Right, in the single fraction, we will have 80 plus 6H over 5 times with 15H. 5 and 15 can be simplified. So now we open up the bracket, we have 240H plus 18H squared. Rewrite so that it is the same as the format given. So 18H squared plus 240H we have just shown. Okay, So this is part A. And next, part B, we have the water that is poured into the container at the rate of 60 cm cube per second. So this is the question involving the rate of change. So let's write dV by dt equals to 60 cm cube per second. Because of this unit, so I know that it is the volume, the rate of change in volume. So we need to find the rate of increase in H. So we are looking for dH by dt when H equals to 10. So let's solve this part, yeah? Okay, we want to find dH by dt. We split this into two parts. And then we chain these two together with the dV by dt given. So chain with dV. Now, do I have dH by dV? I don't have right now, but we can find it on our own. Since V is written in 18H squared plus 240H, so we can differentiate the V with respect of H. That will be 36H plus 240. And when H equals to 10, let's just put the value in dV by dH. You can sub in here, or you put in here, then only you substitute in. Up to you. So dV by dH equals to 360 plus 240. That is 600 here. So let's put this value in here. So dH by dV, but we have dV by dH. So let's write in its reciprocal. Times with dV by dt, which is 60. And this is the height by the base, so the unit will be cm per second. So let's simplify. So 1/10, that is 0.1 cm per second. So that's it for the question number 7.